Hello everyone, we will continue with the previous video. We have seen about QuickSort algorithm. Here the after swapping I and j value, you will be get the list of elements is here. After swapping a of ji is less than or equal to pivot element, you have to check whether the pivot element is less than or equal to the I value and the a of j value is greater than the pivot element. Repeat the process until I and j will be crossed over. When I and j have crossed, swap a of I with the pivot element. Here 5, 3, 4, 19, 7, 12 and 6. After swapping you will be get the number of elements 5, 3, 4, 19, 7, 12 and 6. Here the I and j value will be crossed. You have to swap the a of I value with the pivot value. So a of I values here is 19. Then a of I value is 6. We have to swap these two value. You will be get the 5, 3, 4, 6, 7, 12 and 6, 19. The result will be a of k is less than or equal to pivot element for k is less than I value, and a of k is greater than or equal to pivot for k values greater than I value. Picking up the pivot element. There are several ways to pick a pivot element. Objective one is we have to choose a pivot element so that we will get two partitions of almost equal sizes. Use the first element as pivot. If the input is random, okay. If the input is pre-sorted, all the elements go into S2 or S1. This happens consistently throughout the recursive calls, results in B of n squared. Behavior, we analyze the case best case analysis. Then choose the pivot element randomly. Generally safe, but random number of generation can be expensive and does not reduce the running time of an algorithm. Then picking the pivot element strategy 3. Use the median of the array. Ideal pivot, the n by 2th largest element. Partitioning always cuts the array into roughly half. An optimal quicksort big of n log n. However, hard to find the exact median. Median of 3 partitioning eliminates the bad case of sorted input, reduces the number of comparisons by 14%. Then median of 3 methods will be compared just 3 elements, the leftmost, rightmost and center. Swap these elements if necessary so that a of left is equal to smallest, a of right equal to largest, then a of center will be the median of the 3 numbers. Then pick a of center as the pivot. Swap a of center and a of right minus 1 so that the pivot is at the second last position. Here is the some pseudocode for picking of the pivot element. If int center equal to left plus right divided by 2, that means you will be you will be head you will be divide the leftmost element plus rightmost element will be by 2 means you will be get the median of 3 elements. If a of center is less than a of left side means swap a of left side with a of center element. If a of right side means right side less than a of left side means swap a of left with a of right. If a of right is less than a of center means swap a center with a of right side element. Here is the another one example for median of 3 elements. This is the pseudocode for quicksort element. If left plus 10 less than or equal to right means quicksort a of left comma I minus 1, quicksort of a comma I plus 1 comma right side. Sort the smallest element for the first code, then the sort larger element for the second code. Here is the partition part. The partition code we just saw works only if the pivot is picked as median of three elements. A of left side is less than or equal to pivot and right side is greater than or equal to the pivot element. Need to partition only.